Okay. Fabricio, tell us one of those hints that we might use in this problem. Okay, they look equally complicated. They're a fraction, right? You have some math operations in there. Okay, what's another hint? We eventually might need to change them all into sine and cosines, okay? But for now, we're going to keep it as is. Any others? Okay, I'm only going to use factoring if I see something like a greatest common factor, okay? Now, a type of factoring, or something we're going to use eventually on in this type of problem, is we're going to multiply by the conjugate. Partner B, tell partner A what is the conjugate of the denominator. Ready, set, go. Class, what's the conjugate? Secant theta plus tangent. Okay, remember that in math you can multiply any expression times 1. And multiplying here by the conjugate might lead us somewhere, okay? So what I want you to do is this. With your partner, I want you to simplify the numerator. So again, we have multiplication, and then you're going to have to multiply a binomial times a binomial. Okay? I'll give you guys 80 seconds, and then we'll check in. Ready, set, go. All right, Marianne. Let's go ahead and multiply the denominator. So I'm going to use a box, which is essentially the same thing as FOIL, or multiplying a binomial times a binomial. Mariana, secant times secant. Mariana, secant times tangent. Yeah, whatever you pick, just be consistent. So if you put secant first, then keep putting secant first. Mariana, negative tangent times secant. Yep. And Mariana, negative tangent times positive tangent. Thank you. So we just multiplied. Now, Cole, we're going to combine like terms. Do you see any like terms in there? Yep. Tell me what's left. Thank you. Now, if you look at what we're trying to do here, we're trying to make this side look like this side. We just did the conjugate, and if you notice something, I have the secant plus tangent that I want. So I'm not going to distribute. I'm not going to change the numerator into sines and cosines because there's a piece right there that I want to keep. So I'm just going to write this as is. Okay, we're almost there. Somehow, all of this, or including this, turns into a sine. Talk to your partner about the two different types of identities we might need to use in this problem. You guys have 50 seconds, right? So go. Josh, which identity do you think I'm going to use with the one in yellow? You can look over here. I see cosecant. I see sine. Look at your formula sheet. I'm sorry? Which identity are you using? Your choices are P, Q, R.
The R.
The R, he says. Thumbs up, thumbs down? The reciprocal identity is correct.
That's right.
Josh, what is it?
1 over sine.
Correct. Mary Grace, the one in blue. The Pythagorean identity. Okay, this one's a little bit more difficult. Tell me the Pythagorean identity. It has tangent squared and secant squared in it. Can you turn off the speaker? Thanks. Mary Grace, how do I make this Pythagorean identity look like this one? You what? Move the tangent. Mary Grace, what's left? So, Mary Grace, for all of this, what am I going to write? We're going to write 1. And Marisol, what's left in the numerator?
Theta plus theta.
So to clean it up, I just have secant of theta plus tangent of theta all over sine of theta. Kind of made it messy. We did our side work over here. So basically it's an identity because we worked on the right hand side to make it look like the left hand side. In this problem I had to multiply by the conjugate, use a reciprocal and a Pythagorean identity, and we verified it.